From the Library of Congress in Washington, D.C.
I'm an editor at the Washington Post who, for the past few years, has worked with the health, science, and environmental team, which makes making this particular introduction a particular joy. The Post has an absolute dream team of science writers, one of whom you heard from earlier on, Joel Achenbach, and Marc Kaufman, who you're going to hear from in a few minutes. Like other reporters, they cover breaking news, they write about features, but what I love most about writing with them is they take readers places you never would have dreamed of going on your own, down to the bottom of the sea or way out into outer space. Their ambition knows no bounds, their curiosity is contagious. And curious is an adjective often applied to Marc Kaufman. He lives with his wife Lynn, who's sitting here too, in a wonderful house not far from here in Silver Spring, way up among the trees, where he can look down on the natural world around him. And he loves it. He loves watching nature out there. And he spent much of his career writing about the connection between people and nature. He lived in New Delhi as a foreign correspondent for the Philadelphia Inquirer and went to Afghanistan later on from the Post after 9/11. Now, when you look back on the stories then that he wrote, you see they weren't really about world leaders as much as the relationship with between the people who lived in those countries and the world they lived in. They were more anthropology than foreign policy. Marc brought that same curiosity to science writing, but it wasn't an obvious step for him. I heard from another science editor, a former editor at the Post the other day, about how he made that transition. He said to Marc, "So, come on, I'd like to have you on science writing and writing on the NASA beat." And Marc apparently resisted. He said, "I like writing about people, about nature, about the world," he said. And he said, "There's no life out there." Of course, now we've discovered that he spent his time working on a book about life out there. It's a book that's full of the enthusiasm Marc has for the rest of the world, full of wonder and awe. And along the way, you'll learn curious facts, as I did, such as the fact that a Dyson sphere isn't a new kind of bagless vacuum cleaner. Anyhow, one of Marc's mottos is "Time is short, use it well." This time is much better used by Marc than me. Please join me in welcoming Marc Kaufman, author of First Contact.
Hello, everybody. It's such a delight to be here. Thank you so much for coming. I couldn't help but notice as I was looking through the program that most of the people speaking yesterday and today are not from the worlds of science, but rather from the world of biography or fiction or poetry. And it struck me as then interesting that since I am one of the few who's speaking about science, I'm speaking about a subject that is a little bit on the edge of kind of science and fiction. So it kind of merges in with some of the other themes. But what I hope to do today, in addition to telling you a little bit about myself, is to explain how and why the search for life beyond Earth is really much more now about the science and fact rather than about fiction. We are very close to a moment that might be one of the greatest scientific moments of all time, and it may well happen in our lifetime. So that's what I will be speaking about in the minutes to come. But just first a little bit about myself. I have, as Francis said, have not been a science writer for such a long time. I've been a foreign correspondent and love to wander the world and meet interesting people and the connections there. But I did indeed agree with my editor to give NASA a shot, and boy, I am so glad that I did. What an absolute treasure trove of magnificent stories. Just a side note for a sec, a study was done recently of the most emailed stories on the New York Times website. And the category that came in top, most emailed, was stories that reflect the wonder and awe of the universe and of life. And I found that to be kind of reassuring because it was also reflective of what I and other science writers at the Post have found, which is that fortunately there's a great appetite for the kinds of things that we do. So after being asked to take this beat, since I didn't know a whole lot about science, and truth be told, I can now say, now that the book is out, I never did take a physics class, and I think the last science class I took probably was in biology in high school. But I've been a reporter for 37 years, and what that does is it teaches you how to ask questions. And as we'll see, that's what this was all about, was going around and asking a lot of questions. But how it all began was I went up to a boot camp, a science boot camp for journalists at MIT. It was on the universe. We were going to learn everything about the universe in 4 days, and almost did. One of the last speakers was this very, very dynamic young woman who just burst with enthusiasm. I later learned that she became a tenured and chaired professor at MIT at age 34, the youngest professor ever to achieve that. And her specialty was astrophysics and understanding or theoretical astrophysics and understanding the atmospheres of exoplanets, planets beyond our solar system. And she stood up in front of us and said, in very declarative kind of terms, in your lifetime, there is or in any case, in my lifetime, she said, there is every reason to believe that we will find life beyond Earth. And I was sitting in the audience then, still as a reporter rather than a science reporter per se, and that little thing inside of us that gets trained to respond to potentially big stories said, my goodness, what a story. You know, that we're going to find life beyond Earth in our lifetimes. You know, who knew? And that started me on a process that resulted in this book, resulted in my circling the globe twice, basically. It took me to the deep mines of South Africa, to the Atacama Desert in Chile, and all around the world. I wanted to go out and see where people were doing the real cutting-edge work, but also I had an ulterior motive, which was that I needed to be with these people, with these folks who were the top of their field, for a period of time so that I could understand what they were saying. I needed to repeat the questions a number of times and over days for it to sink in. And I tell you this only because it's part of a process that I hope resulted in a book that speaks to people who are scientists, but also non-scientists. I had to understand what these folks were saying before I could write something. And as a result, hopefully other people would understand them too, and that's the feedback that I've gotten. But in any case, this is a book that's based in science, that's based in discoveries, that's based in things that are happening every week. There's some kind of new discovery going on. The field is called astrobiology. 10 years ago, the giggle factor associated with it was still fairly high. You're looking for life beyond Earth, it's UFOs, it's green guys, and so on. That's not true anymore. It's considered a very, very cutting edge, sophisticated kind of field now, bringing in lots of very good people. And this, I'm going to now paint a little bit of a picture of what they have found and why that opening statement that life beyond Earth is most likely going to be found soon, relatively soon, why that might be true. The first thing is that it turns out that life is far, far more tenacious than was ever imagined until fairly recently. It's a world called extremophiles, microbes, bacteria, that we now know live in conditions that 5, 10 years ago science thought were absolutely impossible to support life. And by that I mean there's something called black smokers, which are hydrothermal vents at the bottom of oceans. You've got very, very hot water and other things coming out up to 700 degrees Fahrenheit. The research into those discovered, to everyone's surprise, that there were living creatures, microbial life, not right at the center, but fairly close to the center, you know, with over 200 degrees, I believe. Similarly, Antarctica is now considered to be a biosphere. And it's not because of all the researchers there at McMurdo, but rather because everywhere that they look, in the ice, they find microbial life. Going down 2 miles, you know, in the middle of glaciers, everywhere. And as was explained to me, when ice crystallizes, you get that H2O in the middle. Everything else gets kind of squirted out to these little rivulets around it. And that means that if there's microbial life, it then gets salts and other things that it could live on. And so you have this environment. I visited a professor at LSU who goes down to Antarctica a lot. He had these big chunks of ice down in his cold room at LSU, and he would, you know, bring them out, and it's not like you could see the microbes, but he said, you know, we look through here and we will probably find, you know, millions of microbes. Similarly, the Atacama Desert, driest place on Earth, rains once every 10 years in some places, microbial life living under some of the stones. And most interesting to me, because it got me going in some of my reporting, right below us, a mile, 2 miles, there's every reason to believe that you will find microbial life. This, again, is something that was not understood until 10 years ago or so. A researcher at Princeton named Tullis Onstadt, on a hunch, without any funding, made arrangements to go down into the deep mines of South Africa. That's the deepest cut into the earth that exists. And he went down there, and over a period of a couple of years, he began finding microbial life at 2-3 miles below the surface. And what was most remarkable about it was that this life had absolutely no contact with the surface world, and hadn't for millions of years. It used the energy of radioactive decay in the rocks nearby, and was able to produce food for these little microbes as a result. This really revolutionizes our understanding, one, of life. It turns out there's more life below the surface of the Earth than there is above. And by that I don't mean in oceans. This is below the surface of the bottom of oceans. There's more mass of life below us than there is above. And that includes insects, you know, and the mosquitoes and everything. In any case, the implications of this are great for astrobiology, because the Mars we now know is very dry and very cold and has a lot of very harmful radiation that hits the surface. But what about deep underneath? Isn't it possible that there was once life on the surface and that it migrated down and still survives there? And that is increasingly the way that NASA and the world of biology, astrobiology, looks at things, because at the same time there has been a gradual understanding that Mars used to be both warmer and wetter. In fact, there was a period of time, about 4 billion years ago, when it was a lot wetter and a lot warmer, or in any case, a lot warmer and a lot more hospitable than the Earth was, which had just been, not that long ago, had been hit by the moon, or what became the moon. And so the school of thought evolves that said life on Mars may well have been there 4 billion years ago. It's possible we now know that that life came here. It's possible it went down below. Of course, if it came here, you know what that means about all of us. We are Martians. A couple years ago, I went down, I made arrangements, went down into one of these mines. It's a pretty creepy experience. It's very, very dark, wet, hot. A volcano had blown there, I don't know, hundreds of thousands of years ago, but there was still a lot of excess heat. It was like 130 degrees or something. And you walk through and you think, you know, this is just so sterile. You know, it's hot and all you know, and wet, but still the rock itself is what you see. And you can't imagine that there is life in there. But we now know from ONSTAT that, in fact, in the cracks, you know, deep in there, in little lakes or ponds or whatever, in the rocks, that there are living things. And when their boreholes are put in, the water comes out, they could filter it, and they find them. Well, what's perhaps most remarkable, or even more remarkable, I went down with a Belgian researcher who was not looking for microbes, but rather was looking for more complex life. And some of you may have seen a story that ran, I don't know, 6 months ago or so, but what he found, and the paper was published in Nature, meaning that it got very rigorously peer-reviewed, was he found complex life. He found little nematodes, which are worms, which are, you know, millions of times more complex than microbial life, and it was living also deep down. So not only are there microbes, but potentially there could be more complex life deep under the Martian surface or other kinds of surfaces. And as a final shout out, as it were, to Mars as a likely site of our first discovery. Recently, there's been a growing understanding that there has been running water on the surface of Mars in the past, and most recently, there were images that were sent back from the Mars Reconnaissance Orbiter that showed what appeared to be running water on the surface now, today. And this was in a crater, a large crater. It wasn't just one or two streams, it was many streams, and it has, you know, this whole world abuzz. Similarly, we now know that there is the gas methane that is that at particular times, you know, the same time of the year in the same places, comes out of the crust of Mars. And methane, 90% of it is created biologically on Earth. Doesn't mean for sure that that's what happens on Mars, but it sure could. And you know, we now have water, we have methane. The story is getting more and more interesting. In late November, the most sophisticated astrobiology mission to Mars that's ever been done will be launched by NASA. It's called the Mars Science Laboratory, and the rover is called Curiosity. It lands hopefully in August of next year, and will begin telling us things about life and organic materials that we've never known before. So again, we're getting closer and closer to understanding really important things. What also changed the whole world of astrobiology is the discovery of exoplanets, planets beyond our solar system. This is stuff that had been presumed to be the case or speculated to be the case for years and years, but it wasn't until the mid-90s that first a Swiss team and then an American team discovered the first exoplanets, and at this point we now have something like 700 or 800 confirmed exoplanets. We have thousands more candidate exoplanets. And what we've learned is that the chances are very, very high that there are billions of exoplanets, even in our galaxy. Jeff Marcy, who's probably the greatest planet hunter, recently did a survey for NASA, for Science Magazine, and putting together the knowledge that we have, he estimated that there were tens of billions of exoplanets in our Milky Way. Now, the Milky Way has something like 100 to 300 billion stars, and just to make your mind kind of go to places, hopefully where mine has gone lately, you have 100 to 200 billion galaxies. So you put all this together and you have like a really, really long number of potential stars, or stars that potentially could have exoplanets, and we now know many of them do. What we also know, and this is what's really exciting right in the last 6 months or so, was reports that they were finding exoplanets in what are called habitable zones, which means that they're close enough to their star that water can be liquid sometimes, and they're far enough away from the star that it doesn't all freeze. So it's remarkably complicated calculations that they're doing. These are not things that they're visibly seeing, but rather that they're understanding through how stars respond to the presence of other celestial bodies and so on. But the world of exoplanets is just going nuts, and it is presenting a canvas out there for life in terms of where it could possibly go. Added to that is the increased understanding that everything that's needed for life is out in space. You have carbon, you have complex carbons, you have oxygen, you have hydrogen, you have water, you have nitrogen. It's all out there. It's all out in large amounts. And it begins to be plausible to think in a theoretical sense, okay, you have all these planets. You have all these planets. You have all this material. We know that life is incredibly tenacious. Put all this together, and you have a story that says, how could there not be life, given those kind of circumstances? A final thought along these lines. Microbes, everyone says, you might think, okay, no big deal. They're just, single cell, it's not complex. Why is that important? There has been life on Earth for approximately 3.7 billion years. For the first 3 billion years, it was only microbial life. So microbes loom very large in all of this understanding of astrobiology, because they then feed into the whole evolutionary narrative that is essential to understanding all of this. So that's the basic bottom line in terms of the discovery of, or the search for life, which is that forever in humankind, humans have wanted there to be life in the sky. That's where we've put the heavens, we've put gods, in Islam there have been jinns, and in Christian and Jewish tradition, angels. The Chinese have the Jade Emperor, ET, UFOs, everything. But humans have wanted there to be life in the stars or in the sky. We now are at a place where it's not a question of belief, it's not a question of deduction, it's a question of science. And we have the tools and we have the knowledge to find answers in the not too distant future. A final direction to go in, finding microbes on Mars would mean this. If it turns out that these are microbes that are different than anything on Earth, then you have two genesis of life in one kind of chump change solar system. And if that is the case, then the likelihood of life being a commonplace goes up exponentially, which would then mean that you have life you have reason to believe, good reason to believe, that life is everywhere. The big problem, though, in astrobiology is, as important and as interesting as microbes or nematodes are, what people want to know is there intelligent life out there? Is there someone we can talk to or communicate with in some way? And this is where things get difficult. The organization SETI, which probably many of you know about, has been listening for sounds, noises, signals sent from other galaxies for a long time, for almost 50 years. They haven't heard anything. As they tell me, that really doesn't mean anything. What they've looked at so far is the equivalent of 1 cup of water out of the whole ocean. But putting that aside, it's kind of a difficult stretch. Similarly, now they're looking for rays of laser rays, rays of light, and this is not just SETI, although SETI itself has become a major science operation as well as something that you put on your computer and try to help them find stuff. But there also are professors at Harvard and at Princeton who are actively involved in this optical SETI. The big issue in this world now is, do we just listen and do we just wait for people to contact us either through light or through sound, or do we send out messages? It's called METI instead of SETI. This is the messaging of extraterrestrial intelligence. And very controversial within the field. Stephen Hawking, very famously about a year ago, said he thought this was an extremely bad idea because the history of superior civilizations, which we assume would be what's out there, coming to other civilizations is not good. So he said, don't tell anyone. And that coincides with something that I came across when I was in Japan for a SETI observation. It was the first all Japan SETI effort, and at the end of it, this had gone on for a couple days. The astronomer in charge just seemed to be very overwhelmed, and getting all these phone calls, and just being very unhappy with stuff. And I said, Shinwa, what's the matter? And he said, whenever we have something like this, I just get inundated by calls, and people say, don't tell them we're here. It can't turn out good. And so that is one of the areas that hopefully will be on the front burner in the years ahead, because if we do find that there is microbial life on some other planets, or if we find atmospheres on exoplanets, distant atmospheres with a lot of oxygen or ozone in it, well, then we know that there's probably life there, because oxygen doesn't exist on its own. It bonds very quickly. It would have to be, as it is here on Earth, it would have to be recreated, very, very, very quickly. And so if they find oxygen, that could then mean that there's life there. But how do we communicate with it? There we're kind of back into the world of belief rather than science. There's scientific efforts being made to do it, but in terms of what we know, it's not really quite science yet, because, well, we haven't heard anything, haven't seen anything, and we don't know. We know that microbes can evolve into other complex things. We don't know that civilizations can grow, although, we did. I don't see why it couldn't happen somewhere else. So on that note, I thank you very much, and hopefully we'll all be around when that big discovery is made, and I can write the story.
Pre-Galileo, we had the concept of the Earth and humanity as we know it being central to everything. And we knew that. We found out in time that's wrong. We're still operating on the concept that life requires carbon, oxygen, heat, water, etc., etc., etc. Is there any body of study, at least, to say, no, there can be life in addition, or which does not require these things which we feel essential to life as we know it?
Very good question, and it was a question that was posed by the National Academy of Sciences about 3 or 4 years ago, and they brought together some of the best astrobiologists, biochemists, planetary scientists in the world, and they went through, could silicon replace carbon? Does there have to be water? Could there be a different kind of solvent? And the report, which is called Weird Life, it concludes that it's possible, but that it's far more likely that if there's life elsewhere, that it would be carbon-based, just because carbon is the element that, one, is most prevalent in the universe, and two, or one of the most prevalent, and two, it bonds so well with everything else that it makes life more possible. So in answer to your question, it is something that people think about, and they're studying pretty avidly. The betting is that it's carbon-based. Hi.
How you doing?
Good.
I've been reading a lot of this stuff, and I find it very interesting. But one interesting thing is we talk about other possibilities for life out there and evolving into that. Are we not, at least at the human level and the complex living level, seem to be moving away from the dynamic that will allow life? And are we, in the near future, possibly going to move out of that zone? Some say Venus used to be more hospitable, if not totally. Are we moving away from where humans and similar organisms might be able to survive?
Again, a very on-target question. In the world of SETI, there is a lot of discussion of, well, how common would technologically sophisticated civilizations be? And there's a school of thought that says they probably would not be that common, because it appears that when intelligence reaches a certain level, it tends to self-destruct. And since we are the primary example, that's the feeling, that it may well be that there have been other societies, other civilizations that grew, and then they reached a point when they had nuclear weapons, or they did things that made the climate change in a significant way. They overpopulated, and boom, they're not there anymore. So again, in answer to your question, yes, that is conceived, that is seen as a real plausible and explanation of what might happen.
Thank you.
Hi, I wondered if you could comment on the community of scientists that study this. On the one hand, you have, in broad terms, the astronomers, and on the other hand, you have the biologists. And I wonder if you've had a chance to observe these separate communities, and in particular, see these communities interacting with each other.
Yes, and thank you for the question. It's something that I had actually meant to get into, which is astrobiology is probably the most interdisciplinary science on Earth. That's ever existed. It goes from microbiology to geomicrobiology to biochemistry to chemistry to planetary science to geology to cosmology, and in fact, all these people do get together. Every second year, there is a major conference. 7,000 people show up, and they discuss everything from what they're finding in the world of extremophiles to why there are so many crazy kinds of solar systems that are being found that are very different than what anyone had anticipated. So there is, in addition to this connection, there is something that I really have found and tried to paint to some extent in my book, that an awful lot of the people who've made big breakthroughs in astrobiology were kind of risk takers, were people who thought outside of the box, who had been told by the funding agencies and also to some extent their mentors that what they were trying to do was ridiculous, impossible, and they stuck with it, and then they discovered extremophiles, or they discovered that you could, look at exoplanet atmospheres, or you could find all these exoplanets. So it is a very, very broad field. It is a international field. I just, over the summer, was speaking at a conference in Montpellier, France, which was also very well attended. There were people from around the world who came to that. And hey, the book's being published in, South Korea and Japan so far.
Thank you.
Just building on the other comments, I think the fact that we're looking for life based on the chemicals, the elements we know, seems to a number of people to be reasonably limited. We know that a lot of scientific theories get overthrown. In fact, most of them do as we go along. I don't know if you've seen the announcement 3 days ago by the research between the Large Hadron Collider folks and the folks in Italy, shooting a beam of neutrinos and studying them over 3 years, where those neutrinos have been measured within 6 standard deviations to be faster than the speed of light. And when we get into that, that just throws up all of the Einsteinian theory, and to me, based on the connections that you've talked about between the cosmologists and the astrobiologists and the quantum mechanic folks, throws this whole thing about life right up in the air too. I wonder what experience you could relate with those things.
Two things come to mind, or several things. The first is, what an incredibly exciting discovery that is.
Amazing.
It has to be replicated, and one of the things that I've discovered or found is that results don't always turn out to be what you think they are. But here's something that I never imagined to be the case. And an aside, one of the things I loved about this whole reporting process was it was an education of a lifetime. I mean, the things that I was able to learn and hopefully convey in the book. But the universe is expanding at an ever faster rate, which means that in a theoretical sense, that it could be expanding sometime in the future, perhaps now, faster than the speed of light. That there's nothing about the physics that we know that says that it would have to be the same physics out there. But in kind of further answer to your question, science, as a newcomer to writing about, a relative newcomer, the thing I love about it is that it is always open to new discoveries like that, to people breaking all the china. And then I'm sure hundreds of people are now trying to figure out ways to replicate or not replicate that. And in the years ahead, we'll find out.
Thank you.
One other thing, if I could, this is not about the neutrinos. One other thing, if I could, this is not about the neutrinos, but about the other ways of thinking about astrobiology. There was a paper that came out half a year ago again, very controversial. It had to do with Mono Lake and whether or not and arsenic in Mono Lake, and whether a team of researchers had found or had been able to create bacteria that was different than anything that had ever been created before or had ever been found before, in that it had no phosphorus in it. All life has 6 elements, phosphorus being one of them. In this one, arsenic had taken the place of phosphorus. Very controversial, again, has to be replicated, and we'll find out whether or not it's true. But it's a whole idea that if there is life, if life started once on Earth, and everything that's alive now that we know of came from that same source. I mean, we're all, we have the same structure as those microbes and as jaguars and blue jays. But if they find something different, or if they start looking for something different, why wouldn't there have been more than one genesis of life on Earth? I mean, it's a provocative question, and it's not something that we have an answer to yet. But if the place that we know created life, or life was created here, why wouldn't it have been created in different forms, with different basic structures?
Hi, thank you. Could you tell us about the blurb on you talks of the Vatican's concerns with these discoveries? Could you expand on that?
Oh, absolutely, be delighted to. The Vatican had a conference about 2 years ago on astrobiology and the search for life beyond Earth. They had many of the top people in the field, and it was interesting because most people, most scientists and most organizations that I dealt with were just eager to talk. This was the one place where they didn't let me into the meeting. My understanding is that the chief astronomer for the Vatican, and there is such a thing, and they have an observatory in the Southwest, our American Southwest, is someone who has thought a lot about extraterrestrial life and has spoken about how the church is ready to embrace our extraterrestrial brothers. I kid you not. I think what's going on here is, one, the church, like a lot of institutions, is preparing for what could be a really significant change in how we view ourselves as human beings. I mean, if we're not the only life in the universe or in the galaxy, then what are we? How do all of our mythical stories or the religious stories, how do they make sense? So they're trying to do that. They also, unfortunately, had something of a bad, PR with Galileo, and there's even worse, a former Dominican monk named Giordano Bruno back in the 17th century became something of a free thinker and posited that there was life on other planets, that there were other planets first off, and that there was life. And for that and other reasons, the Inquisition burned him at the stake. So he's kind of the patron saint of astrobiology. But it's, I mean, I commend the church, the Vatican, for addressing this in a serious way. And a lot of other organizations are doing that. NASA has sponsored 2 workshops bringing together religious and scientific and political and a lot of other kinds of figures, journalists too, and to try to understand what some of the implications might be. And it really gets fascinating. When you think about the day after, it could be a big deal. But the best recounting of this particular episode of the Astrobiology Conference, I have to tell you, was not done by me, although I did write a story about it for the Post, but rather by Stephen Colbert. And if you Google Stephen Colbert, Vatican, and aliens, you will see a magnificent interview with Guy Consolmagno, who is another one of the Vatican astronomers. Suffice it to say, Colbert, who's a practicing Catholic, said, "Guy, don't you understand that if they find life elsewhere, the religion is done? I mean, it's over, We have reincarnations all over the galaxy. I mean, in any case, he does it much better than I."
Thank you.
I'm sorry, it looks like one question. Is that? I'm sorry. Yes.
Your brothers and sisters in science and religion have informed and inspired you. Your brothers and sisters in biology and astrophysics should be thinking about where they're going to get the next penny or dime or dollar to carry out their research. I've heard that recently funding for these kind of adventures has been decimated. Would you comment on that whole process?
Yeah, I think one of the reasons why they were so eager to talk to me was because, you write a book and maybe people get interested and you get more funding. But yes, this is something that has already severely hurt the program. There was something called the Terrestrial Planet Finder, which was supposed to be the next stage in terms of exoplanet discovery after Kepler, and that was canned for financial reasons. But just a final thought about it, what I find remarkable and very positive about this is that this is a field and this is an endeavor that's going on so many levels in so many places around the world that there is no stopping it. You know, you could slow it, but there's no stopping it because there are just so many Tolis Onstadts and Sarah Seegers who are ready to.
This has been a presentation of the Library of Congress. Visit us at loc.gov.